Hello friends, Mr. Burrell here. We're in Unit 11. We've been talking about solving trigonometric equations, specifically using the unit circle. So we're going to extend that a little bit. We're going to continue talking about solving trig equations. We're going to talk about finding all the possible solutions to a trig equation. So, by the end of this lesson, let me move my face here and grab my calculator. These are the things that you'll be able to do. I hope that you are able to understand what a periodic function is and find all the solutions of a trig function in degrees, and it's not on here, but I also want you to be able to find all the solutions to a trig function in radians. So we're going to talk about radians and degrees, finding all the solutions of a trig function in radians and degrees. So, I have my unit circle. Hopefully we become pretty familiar with the unit circle. So on the unit circle, how often do the values of sine and cosine repeat if I go around? So notice, like, say I wanted to find where the sine of theta equals 1/2. What angle gives me a sine of 1/2? Well, that's going to give me 30 degrees because there's my sine value or my y coordinate of 1/2. And it's going to give me 150 degrees. Because that angle is also going to give me a sine slash y coordinate of 1/2. So my answers would be 30 degrees and 150 degrees. Okay? Up to this point, those have been my answers. Well, I want you, if you have a calculator, I want you to practice something. I'm going to go ahead and pull up my Desmos calculator myself. So I'm going to go ahead and type in sine of 30 degrees in here. Except I'm going to change it to be in degrees instead of radians. So sine of 30 degrees is 0.5. Okay. So if you remember when we were talking about angles back a little while ago, if I was to draw a 30 degree angle, it ends up being like right here, right? But that's not the only angle that has that terminal side. This is technically not the only angle that's going to end right here. Say I go a full circle and then come back to this side right here. That's going to end up in the same place, right? Meaning that it will still have a sine value of 1/2. Well, what's that angle? If I add one full 360 degree revolution, well, let me erase this 150 for a second. That's going to be 30 plus 360, which is 390 degrees. So let me test that in my calculator here. If I type in the sine of 390 degrees, indeed, it's still 0.5. Well, I don't know. What if I were to go around, like, multiple times, more than one time? Maybe I were to go, like, 360, an extra 360. That was a really bad circle. What if I was to go 360, 360, and then that extra 30 degrees? So what if I took this 390 degrees and added 360 again? Well, 390 plus 360, that's going to give me 750 degrees. So technically 750 degrees would also have a sine value of 1/2. Let's double check that. Sine of 750 degrees indeed is 0.5 or 1/2. If I add 360 again, that's the sine of 1,110, still 0.5. If I add 360 again, that's 1,470. It's 0.5 again. You see what I'm doing? Do we see what's happening? So before, in our previous lessons, I gave you kind of a boundary. I said, okay, between 0 and 360 degrees, what are the possible angles that will give me these sine values, or these cosine values, or these tangent values? So on my circle, a sine value of 1/2 gave me two angles, 30 degrees and 150 degrees. All right, so let me erase this, 30 degrees and 150 degrees. But those aren't, if I didn't give you a boundary, those technically aren't the only solutions I could have. Those aren't the only angles that would give me a sine value of 1/2. I could take 30 plus 360, or 30 plus 362 times, or 30 plus 363 times, or 4 times, or 5 times. I can go as many times around the circle as I want. Well, I don't want to write out all those solutions. That would take me literally forever, because there are infinitely many of them. There's infinitely many of them. So instead of writing 30 plus 360 once, twice, 3 times, a million times, I'm going to write 30 plus 360 times n times. I'm just going to use the letter n to say, okay, I'm going to go 360 degrees around the circle as many times as I need to. So my solutions would be 30 plus 360 times n and 150 plus 360 times n. Okay? Meaning that my solutions are 30 degrees plus 360 plus 360 plus 360, or minus 360 minus 360 minus 360, or 150 degrees plus 360 plus 360 plus 360, as many times as it takes. Okay? So, let's practice this. And I'm gonna show you kind of a cool case with these tangent ones. So I'm going to find all solutions, not just the solutions between 0 and 360 degrees, but I'm going to find all the solutions, period, just all the possible solutions. So don't worry about that boundary. Okay, so tangent of theta equals 1. Where does the tangent of theta equal 1? Well, it's not written on my unit circle, but it might be on yours. Tangent values are where tangent is equal to 1 is right here and right here, which is at 45 degrees and 225 degrees. So 45 degrees and 225 degrees. Okay. Note that these are on exactly the opposite ends of the circle. See here? So if I take 45 degrees plus 180, so 45 plus 180 degrees, that's going to give me 225. If I add 180 degrees again, I'm going to get 225 plus 180. That's going to get me right back here at, that's going to be 405 degrees, etc., etc., etc. So there's 2 different ways I could write the answer to this question. On tangent values actually repeat every 180 degrees instead of just every 360 degrees. So I could either write 45 plus 360n and 225 plus 360n, or I could simply just write 45 plus 180n. Either of these would be fine, because my tangent values repeat every 180 degrees, which automatically means they're also going to repeat every 360 degrees. Either of those options are fine. I'll take either of them. Well, number 2 here says 2 equals 3 plus the cosine of theta. Well, shoot! I can't even look at my unit circle until I get this cosine by itself. So, in like fashion as we've already done, I'm going to subtract 3 on both sides, which gives me 2 minus 3 is negative 1 equals cosine of theta. So, on my unit circle, where do I have a cosine value or an x-coordinate, right? An x-coordinate of negative 1. Well, I have an x-coordinate of negative 1 right here, and I think that's it. I think that's the only place where I have an x-coordinate of negative 1. So, in the past, my answer would just be 180 degrees. But since I'm not giving you only between 0 and 360 degrees, since I'm not giving you a boundary, my answer is going to be 180 plus 360 n times. So I can go around this circle n number of times, as many number of times as I need to. So my answer would be 180 plus 360n. Okay, now let's mix it up just a little bit. I'm finding all solutions to each equation in degrees. So for example, here I have negative 1/4 times the tangent of 4 theta equals negative 1/4. Okay, well, how do I undo multiplying by negative 1/4? Some of us are tempted to divide by negative 1/4, which is technically correct, but I'm going to go ahead and multiply by negative 4 over 1, because those will cancel both of those out. Over here, I'm going to multiply by negative 4 over 1. Just flipped the fraction upside down. Those cancel too. The negatives cancel. So I end up with tangent of 4 theta equals 1. Notice here I have tangent of 4 theta. All the other questions just had like tangent of theta. This one I have tangent of 4 theta. Oh no! What am I going to do? Promise you that it's not as bad as it seems. So I'm going to go ahead again, look on my unit circle where the tangent is equal to 1. Well, conveniently, we did this one just a little bit ago. Tangent is equal to 1 right here at 45 degrees and 225 degrees. So my two solutions would be, and it's 4 theta in here instead of theta, 4 theta equals 45, and 4 theta, oh, I should write this over here. 4 theta equals 225. But again, I'm not giving you a boundary that you have to write the angles in, so technically I can add 360n both times. Okay? Well, this is 4 times theta. This is 4 times theta. Theta isn't by itself yet. So how do I undo 4 times theta? Well, I'm going to divide by 4 on both sides. Divide by 4 on both sides. See that? Okay, so those are going to cancel, so I'm just going to be left with theta. And then let's see. 45 divided by 4 is, let me write these solutions up here. 45 divided by 4 is 11.25. 360n divided by 4 is going to be plus 90n. This next one, 225 divided by 4, if I'm looking at this equation, 225 divided by 4 is 56.25. Then 360 divided by 4, again, was 90. So plus 90n. So that would be how I write my solutions. Theta equals 11.25 plus 90n and 56.25 plus 90n. And again, with the tangent ones, as a reminder, you can also, instead of doing both of these solutions, since the tangent solutions technically repeat every 180 degrees, every half circle, I could write my 4 theta equals 45 plus 180n, and then divide by 4 on both sides, which would give me, I think that would give me theta equals 11.25 plus, and then 180 divided by 4 is 45n. Either this answer or this answer would be correct, whichever one you want to. Okay. So, I'm going to do one quick one off of your homework. This is off of your homework assignment, and I'm going to do 1 or 2 other examples. I have number 8 on your homework says 4 equals 5 plus 2 times the cosine of theta over 2. So I need to get this cosine by itself. So I'm going to go ahead and subtract 5 on both sides, which gives me negative 1 equals 2 times the cosine of theta over 2. I have 2 times the cosine, so I need to divide by 2 on both sides, which gives me negative 1/2 equals the cosine of theta over 2. The cosine's by itself. Let's look on my unit circle for the cosine or x-coordinate is negative 1/2. Well, right there and right there. So in those two spots at 120 degrees and 240 degrees. So I have theta over 2 equals 120 degrees plus 360n, because I can go all the way around the circle and get to the same place, have the same cosine value. And then I'm going to have theta over 2 equals 240 plus 360n. Okay? Well, theta is not by itself yet. It's being divided by 2, so in order to undo that, I need to multiply by 2 on both sides. So I'm going to multiply by 2 on both sides. Those will cancel, and I'll be left with theta equals 240 plus 720n, and I'll be left with theta equals 480 plus 720n. So those would be my two solutions, or my two answers. Okay, so I've done a bunch in radians. I just want to show you one or two I've done a bunch in degrees, pardon me. I just want to show you one or two in radians, because it's going to be basically the exact same thing. So let's start solving this one right here, for example. So I have 2 plus a sine of negative 3 theta equals 1. So I'm going to go ahead and subtract 2 on both sides, because I want to get this sine part by itself. So I have sine of negative 3 theta equals 1 minus 2 is negative 1. So where on my unit circle is the sine value negative 1, or the y-coordinate? Right here. If I was talking in degrees, I'd write 270, but since I want my answer in radians, I'm going to write it as 3 pi over 2. So, scratch this out for a second. I'm going to write my answer down here. So my answer, negative 3 theta, because that's what I'm taking the sine of, negative 3 theta, is equal to 3 pi over 2. But that's not my only solution, right? If I gave you a boundary, like on these problems, I would, in the past, say, give me an angle between 0 and 2 pi, for example. But now I'm not giving you a restriction. I'm not giving you a boundary. So technically my answer is going to be 3 pi halves plus a full rotation around my circle in radians is 2 pi. So 3 pi over 2 plus 2 pi n. I'm going to write that n on the end so I know that I'm going 2 pi times around the circle as many times as I want. Okay. Well, I have negative 3 theta, so I'm going to need to divide by negative 3 on both sides. So this needs to be divided by negative 3, and this needs to be divided by negative 3. So this whole thing. I'm going to go ahead and write this like this. This divided by negative 3, and this divided by negative 3 right here. So those are going to cancel. I'm going to be left with theta equals, notice here I have like a 3 on top and a 3 on the bottom, so those are going to cancel. And this negative is just going to come along for the ride. So I'm going to have negative pi on the top, 2 on the bottom. Here I'm going to have 2 pi n over 3, and this minus, again, is going to come along for the ride, so this is just going to be minus 2 pi over 3n. So my answer would be negative pi halves minus 2 pi n over 3. If I were to go back to like one of these, for example, if I came back to this answer right here, where I had the cosine of theta equals negative 1, I'd be able to have the same solution here if I did it in radians. Instead of 180 plus 360n, it would be pi plus 2 pi n. 180 degrees is equal to pi, 360 degrees is equal to 2 pi. So I could really write that as pi plus 2 pi n if I were wanting my answer in radians instead of degrees. I'll leave this one up here if you would like to try that one on for size as well. And this one on here if you would like to try a couple of these on for size in radians. But that's it. I hope that you're able to... Oh, these are... Let me go back to my original objectives. I hope you understand what a periodic function is. A periodic function one is one that just repeats. When I'm looking at my unit circle, these trig functions are going to repeat over and over and over. That's what a periodic function means. And hopefully you feel comfortable finding all the solutions of a trig function in degrees and radians, not just the solutions that are in the unit circle. So I hope that was helpful. I hope that you enjoyed that. Please let me know if you have any questions whatsoever. Don't hesitate to reach out to me. And I hope that you enjoyed that as much as I did.